we get this particle moving along a coordinate axis. So this particle is moving along a straight line. Given that this is a complicated equation for this sucker here, that means it's not moving along at a constant speed. So it's speeding up, it's slowing down, it might be going forward, it might be going backwards. It might not be a bad idea to graph that sucker to see what it looks like. Before I do that, I'm just going to run a few calculations. I'm asked to find the velocity at what do we got here, seconds? Does it tell us the units here? It does not say, it just says time and position. Okay, so we're just going to make some shit up here. Let's say that S is measured in meters just for fun. Gives me some context, and let's make T measured in seconds. And then the scenario is there is this axis, this straight line. And on that axis, we've got this particle. Right here. And it is moving along the line. And it's speeding up, slowing down, backwards and forwards. It's doing crazy stuff according to that equation right there. We'll look at the graph to get a better idea of its movements. Next thing I need to know is if S is position, then what is velocity? So velocity V. That's the rate of change, the derivative with respect to time of my position function, which is t cubed minus 5t plus 3. And we're getting good with these shortcuts. So derivative of t cubed is 3t squared. Derivative of negative 5t is negative 5. And the derivative of 3 is 0. So that's my velocity function. In particular, I was asked, what is the velocity at 1 second into this thing's movement? So that would just be 3 times 1 squared minus 5, which is 3 minus 5 or negative 2. So at once, if we observe this thing moving 1 second in, we're going to find it's moving at negative 2 meters per second. And we'll work on answering those questions in just a second. We're also asked to find acceleration. So acceleration. And acceleration, we call that A, evaluated at t, and that's the derivative of the velocity. My velocity function is 3t squared minus 5. It's also the second derivative of position, which means take a derivative and then do it again. So let's see, derivative of t squared is 2t times 3 gives me 6t. Derivative of negative 5 is 0. So that's my acceleration. And I'm asked, and acceleration is how it speeds up and slows down. How fast does it speed up? How fast does it slow down? So the rate of change of speed, velocity. Acceleration at 1 second in. All right, so that would be 6 times 1, which is just 6. Now, what are the units there? Well, we took the rate of change of velocity. So velocity over time, so velocity per second. Well, what is velocity? Velocity is meters per second. So that means what I have here is meters per second, which we often write as meters per second squared. But I always find the idea of a square second pretty bizarro. Like I get what a square meter is, or a square foot, or a square centimeter, but what does it mean to have a square second? What it means is it's a per second. That is, we're looking at the speed change. So I think this is really the better way to look at what acceleration means, meters per second. All right, what do these things tell us? All right, so the velocity is negative. So that means instead of going away from the observer, it's heading towards the observer. And if positive was to the right, like this right here was 0, and maybe this is 1 and 2 over here. So positive is this direction, then negative must be the other direction. So this negative 2 meters per second means that at the instant I observe 1 second in, it's actually moving to the left. at 1 second in. All right, now what's the acceleration tell me? The acceleration tells me is the speed is increasing, because this is a positive number, right? 6 is positive, and we'll look at the graph to think about this. Positive acceleration, positive change in velocity. That means the velocity is increasing at this second, at that 1 second in. That is, the speed is increasing, velocity is increasing. Since the speed is negative at that instant, that means it's going to be becoming less negative. As we look over in time here, we should find it's less negative. So let's see. So I did, it looks like I answered most of these questions here. I have the speed, it is -2. And that tells me that the particle is moving, let's see, right to left. It's going to the left side if positive generally means to the right, which it does. All right, so that would be my answer right there. It's heading to the left. The acceleration at that moment was 6. And again, if position is in meters, then velocity is meters per second, and acceleration is meters per second per second. And it is a positive number, so that means the velocity is increasing. It's a positive change in velocity, so that means it is speeding up at that instant in time. Let's see if the graph verifies what I'm saying here. And now let's see, let's switch over to Desmos for a minute instead of GeoGebra. They're both beautiful. And we need to see our position function. So I'm going to call it S of X, and it was equal to T raised to the 3rd power. Is it -3, no, -5T plus 3? Got to double check. -5T plus 3, yes. Oh, and it's X's, not T's, sorry. Otherwise, program gets confused. X's. All right, so there's my function right there. And I'm only concerned about the time after 0. So this isn't actually how it moves through space. Remember, it's stuck on a straight line. Let's zoom in a bit here. All right, I'm only concerned about like this part of it right here. And in particular, I'm only concerned about what's happening at that point right there, the point 1, -1. So let's put that point on there, parentheses to start a point, when X is 1, and then S of 1, since I named it. All right, so there's my point there. And I can definitely see that there is a negative slope going on at that point. Now, the next thing I want you to imagine is let's put some other points on here. Like suppose I look at the point when a half a second in, so 0.5 comma S of 0.5. Oh, actually, no, let's do something fun. We haven't done anything like this yet. I'm going to throw a slider in here. I'm going to call it A. And let's start off with A equals 1. And then what I'm going to do is I'm going to make a tangent line here. Now, to do that, I need the tangent line function. So we just discovered the velocity function V was equal to 3x squared. Oops, oh, I need V of x first. Equals 3x squared. This is going to be fun. And then -5, right? That's what we calculated earlier. So that tells me the slope at any point here. Now, I don't really need to see it. I just want to use it. So this A is going to be my X value, but I can make it move. So I want to graph the tangent line. Well, what's the tangent line? The tangent line would be Y minus Y1. So Y minus, and my Y's come from this function S. So I'm just going to type S of my slider point A. And then that's equal to the slope. That's my V of X. I want to know what the slope is at whatever A is. The moment A is 1. And then times X minus A. So what this does right here is I've just graphed the tangent line to this curve when A is 1, but because I used A as a variable here, I can move it. right? So if I made a equal to 1/2, then what I'm going to get is a steeper line, which means, right, that means it's moving faster when a is equal to 0.5, half a second in. But it's moving in a negative direction, right? Because the velocity is negative there. And then as I move through time, a is moving through time here. If I move just a little bit past 1, then I'm going to get a more shallow line as I move through there. And my claim is that means it's speeding up because the slope is increasing. So the slope goes from, let's see, I guess we should graph the slope here. What should we call the slope? I'm going to call it m. And m is just the velocity at whatever number a I'm talking about here. All right, so right now the slope is -4-ish. As I move a over a little bit, the slope becomes negative. When I get to, when I get to a equals 1, the slope is -2, which we calculated earlier. As I move through time, when at 1.2 seconds, the slope is -0.6. So the slope went from -4 to -2 to -0.6. That is increasing. We get from a negative number like 4 to -2. And then all of a sudden, when I get over the other side here, now I have positive numbers. And you can definitely see the speed is increasing on that side. Oh, no.